In the endless darkness of deep space, surrounded by distant stars and silent galaxies, a small spacecraft continues a journey unlike anything humanity has ever attempted. Far beyond the planets we know, traveling through the cold emptiness between worlds, Voyager 1 drifts silently through the cosmos. It has no crew, no destination, and no chance of ever returning home. Yet this tiny machine carries something extraordinary, a message from Earth. This is the story of Voyager 1, the most distant human-made object ever created, a spacecraft launched nearly half a century ago that still whispers signals back to our planet from the edge of the solar system. The story begins in the early 1970s, inside the busy laboratories and mission control rooms of NASA. Scientists and engineers were planning an ambitious mission that would change our understanding of the solar system forever. Humanity had already walked on the moon, but the giant planets beyond Mars were still mysterious worlds, seen only as distant dots through telescopes. Jupiter, Saturn, and the frozen frontier beyond them remained largely unexplored. Then astronomers discovered something remarkable, a rare alignment of the outer planets that happens only once every 176 years. This alignment would allow a spacecraft to use the gravity of each planet to slingshot toward the next, traveling farther than ever before. NASA called this opportunity the Grand Tour, and to take advantage of it, two spacecraft were built, Voyager 1 and Voyager 2. Engineers spent years designing a spacecraft capable of surviving the harsh and unforgiving environment of deep space. Voyager would carry powerful cameras, scientific instruments, radiation detectors, plasma sensors, and a large antenna capable of sending signals across billions of kilometers back to Earth. But attached to the side of the spacecraft was something very different, something symbolic. A small golden disk known as the Golden Record. Created by a team led by astronomer Carl Sagan, this record was designed as a message from humanity to the universe. Etched onto its surface were instructions showing how to play it. Inside were sounds and images from Earth, greetings in dozens of languages, music from different cultures, the sound of wind, thunder, ocean waves, laughter, and the cry of a newborn baby. It was a time capsule of our planet, a greeting from humanity meant for whoever might find Voyager in the distant future. On the morning of September 5, 1977, at Cape Canaveral in Florida, a massive rocket stood ready on the launch pad. Engineers watched from mission control as the countdown reached its final seconds. The engines ignited with an explosion of fire and smoke, and Voyager 1 rose slowly into the sky, beginning its historic journey into space. Soon after leaving Earth's atmosphere, the spacecraft separated from the rocket and began traveling alone through the darkness of space, leaving its home planet behind forever. Voyager's first destination was the giant planet Jupiter. In 1979, the spacecraft finally arrived and sent back images that stunned scientists around the world. Jupiter's atmosphere appeared as a vast ocean of swirling clouds and violent storms. The famous Great Red Spot, a storm larger than the entire Earth, raged across the planet's surface. But the biggest surprise came from one of Jupiter's moons, Io. Voyager discovered massive volcanic eruptions blasting material hundreds of kilometers into space. It was the first active volcano ever seen on another world, proving that distant moons could be far more dynamic than anyone imagined. After its historic encounter with Jupiter, Voyager continued its journey towards Saturn, the ringed giant of our solar system. When the spacecraft arrived in 1980, it revealed breathtaking images of Saturn's magnificent rings, thousands of delicate bands made of ice and rock orbiting the planet like shimmering rivers of light. Voyager also studied Saturn's mysterious moon, Titan, a world hidden beneath a thick orange atmosphere. Scientists realized Titan might contain complex organic chemistry similar to the early conditions that once existed on Earth. With its planetary mission complete, Voyager continued traveling outward into the farthest reaches of the solar system. In 1990, scientists decided to turn the spacecraft's camera back toward home one final time. From nearly 6 billion kilometers away, Voyager captured a photograph that would become one of the most famous images in human history. In the picture, Earth appears as a tiny speck of light, less than a single pixel, floating in a beam of sunlight. Carl Sagan called this image the pale blue dot, reminding humanity that every person who has ever lived, every civilization, every triumph and tragedy in human history, happened on that small point of light suspended in the vastness of space. Voyager's journey did not end with the exploration of the giant planets. After completing its historic encounters with Jupiter and Saturn, the spacecraft continued moving outward, deeper into the darkness of space, traveling toward the farthest boundary of the Sun's influence. This distant region is known as the heliopause, a vast invisible border where the powerful solar wind from our Sun finally meets the cold pressure of interstellar space. For decades, scientists waited to see if Voyager would survive long enough to reach this mysterious frontier. Then, in the year 2012, something extraordinary happened. Voyager 1 officially crossed the heliopause and entered interstellar space, the region between the stars. For the first time in human history, a spacecraft built on Earth had left the protective bubble of our solar system. Voyager became the most distant human-made object ever created, traveling where no probe had gone before. It was a historic milestone for science and exploration, proving that humanity could reach beyond the boundaries of our own star. Even today, many decades after its launch in 1977, Voyager continues to send faint signals back to Earth. These signals are incredibly weak, traveling across unimaginable distances of space. They cross more than 20 billion kilometers before finally reaching our planet. Because Voyager is now so far away, each signal takes more than 20 hours to travel from the spacecraft to Earth. When scientists send a command to the probe, it takes another 20 hours for the response to come back. Communication with Voyager is therefore like speaking to a distant echo in the universe. To capture these tiny whispers from deep space, NASA relies on a powerful network of giant radio antennas known as the Deep Space Network. Massive satellite dishes located in different parts of the world constantly track Voyager's position and listen for its signals. These antennas are so sensitive that they can detect transmissions weaker than the power of a household light bulb across billions of kilometers of empty space. Through these faint signals, Voyager continues to share valuable scientific data about a region of space that no spacecraft has ever explored before. The instruments on board Voyager measure cosmic rays, magnetic fields, and streams of charged particles drifting through interstellar space. These measurements help scientists understand the environment that exists beyond the influence of our Sun. It is a region filled with energetic particles, mysterious plasma, and the faint magnetic fingerprints of distant stars. Each piece of data sent by Voyager provides new clues about the structure of our galaxy and the boundary that separates our solar system from the vast interstellar ocean. Today, Voyager 1 is more than 24 billion kilometers away from Earth and continues moving farther into the galaxy at incredible speed. Traveling at roughly 17 kilometers per second, the spacecraft slowly drifts through the darkness between the stars. The Sun that once powered its journey now appears only as a bright star in the distance. From Voyager's perspective, the entire solar system has become a tiny neighborhood left far behind. Yet Voyager's mission will not last forever. The spacecraft is powered by a radioisotope generator that slowly loses energy over time. Engineers have carefully managed the probe's power for decades, gradually turning off instruments to conserve electricity. Eventually, sometime in the coming years, Voyager's remaining systems will shut down completely. When that moment arrives, the spacecraft will finally fall silent. Its antenna will stop transmitting, and the stream of data reaching Earth will come to an end. But even after its voice fades, Voyager itself will continue its journey. With no engines to stop it and no obstacles in its path, the spacecraft will drift through the Milky Way galaxy for millions of years. Long after humanity has changed, evolved, or perhaps even disappeared, Voyager will still be traveling silently through interstellar space. Attached to its side is the Golden Record, a small golden disk that carries humanity's message to the cosmos. Encoded within the record are sounds, images, music, and greetings from the people of Earth. It is a snapshot of our civilization, preserved in metal and sent into the galaxy as a greeting to whoever might discover it someday. Perhaps millions of years in the future, Voyager may pass near another star system. Maybe an advanced civilization will detect the strange object drifting through space, If they recover the probe and learn how to play the golden record, they will hear the sounds of our planet. The wind blowing across landscapes, waves crashing on distant shores, birds singing, music playing, and voices speaking greetings from dozens of languages. In that moment, Voyager will fulfill the purpose it was given so many decades ago, to carry the story of Earth B.
Even as Voyager travels farther away from the Sun, its journey continues to reveal something remarkable about the nature of space itself. For decades, scientists believed the region beyond our solar system would be almost empty, a quiet and motionless void. But Voyager's instruments began to tell a very different story. The space between the stars is not silent at all. It is filled with energetic particles, magnetic waves, and streams of cosmic radiation moving through the galaxy at incredible speeds. When Voyager crossed the heliopause, its instruments detected a sudden increase in cosmic rays, high energy particles that originate from distant supernova explosions and powerful events across the universe. For the first time, scientists were able to measure these particles directly in interstellar space. This discovery helped researchers better understand how our solar system acts like a protective bubble, shielding Earth and the other planets from some of the most dangerous radiation traveling through the galaxy. The spacecraft also began measuring the density of interstellar plasma, an extremely thin gas made of charged particles that fills the space between stars. Even though this plasma is incredibly sparse, it plays an important role in shaping the structure of the Milky Way galaxy. By listening to tiny vibrations and disturbances in this plasma, Voyager has helped scientists map the invisible environment surrounding our solar system. What makes these discoveries even more extraordinary is the age of the spacecraft itself. Voyager was designed in the 1970s, long before modern computers, smartphones, or advanced digital technology existed. Its onboard computer has less memory than a simple calculator today. And yet, despite its age, the spacecraft continues to function after more than 4 decades in the harsh conditions of space. Engineers at NASA have worked carefully for years to keep the probe alive. One by one, non-essential systems have been turned off to conserve power. Small adjustments are made to ensure the spacecraft can continue transmitting data back to Earth. Each time a signal is received, it is a reminder that this tiny machine is still operating billions of kilometers away from home. The distance between Voyager and Earth is now so vast that even light itself needs nearly a full day to travel between them. When Voyager sends a message, it races through the darkness of space at the speed of light, crossing billions of kilometers before finally reaching the giant antennas of the Deep Space Network on Earth. Scientists must wait patiently for these signals, knowing that each message represents information gathered at the very edge of human exploration. Despite its incredible distance, Voyager still moves steadily forward through the galaxy. Every second, it travels farther away from the Sun, leaving our solar system deeper behind. In tens of thousands of years, the spacecraft will pass near other stars within the Milky Way. It will become a silent traveler, moving among stellar systems long after its mission has ended. Astronomers have even predicted some of the distant paths Voyager may take in the far future. In about 40,000 years, Voyager 1 will pass relatively close to another star called Gliese 445, located in the constellation Camelopardalis. Although the spacecraft will still be extremely far from the star, it will briefly enter the neighborhood of another solar system, a quiet visitor from a distant world. By that time, Voyager's instruments will be silent and its systems long shut down, but the spacecraft itself will remain intact, continuing to drift through the galaxy like a cosmic time capsule. And attached to its side will still be the golden record. This record was never meant for humans to hear again. It was designed as a greeting to the universe, a message placed aboard a spacecraft that might wander through space for millions of years. Etched into the record are images of life on Earth, mathematical instructions describing our location in the galaxy, and sounds that represent the diversity of human culture. There are greetings spoken in many languages, including simple words that say, "Hello from the people of planet Earth." There is music ranging from classical symphonies to traditional folk songs. There are sounds of nature, thunder, rain, wind, and animals. Together, these recordings create a portrait of our civilization, preserved in case Voyager is ever discovered by another intelligent species. Whether or not that moment ever happens is unknown. Space is unimaginably vast, and the chances of Voyager being found